What is your concept of what truly sustains life on Earth? Every day, the sun sends us a colossal amount of energy, and this energy is the driving force behind practically everything that happens here. From the cycle of the seasons to the movement of the oceans and even the complexity of life. Everything depends on this solar energy. But did you know that this energy is also constantly dissipating? That's right. It doesn't remain stored in one place forever. It spreads out, transforms, and eventually disperses. And this dispersion, this process of losing organization, is what physicists call entropy. Entropy is one of the most fundamental concepts in physics, but it's also one of the least understood. Essentially, entropy is a measure of disorder in a system. Imagine a perfectly tidy room. Now think about what happens when you start moving things out of place. Gradually, the room becomes messier, more chaotic. This growing mess is a simple representation of increasing entropy. Another example that might help. Think of a hot cup of coffee that you leave on the table. Over time, the heat from the coffee disperses into the surrounding air, and the drink cools down. This happens because the thermal energy from the hot coffee spreads out until the coffee and the environment around it reach the same temperature. This process is entropy in action. Energy tends to disperse, creating balance in the system. What's more interesting is that this increase in entropy doesn't just happen in your room or in your cup of coffee, but throughout the entire universe. In fact, one of the most fundamental laws of physics, the second law of thermodynamics, tells us that the entropy of the universe always increases. This means that over time, everything tends to become more disorganized, more chaotic. But if entropy always increases, why isn't the universe in complete chaos yet? Why does order still exist, such as the complexity of living beings or the structure of galaxies? The answer lies in the delicate balance between energy and entropy. Although entropy tends to increase, there are processes in the universe that temporarily create order out of chaos. This is why we see stars forming from clouds of gas, planets orbiting stars, and of course, life emerging on planets like Earth. The sun, for example, is a ball of incandescent gas that generates energy through nuclear fusion. This energy not only lights and warms the Earth, but is also essential for maintaining life. Plants use this energy to perform photosynthesis, a process that converts sunlight into chemical energy stored in sugars. These sugars are then consumed by animals and, through a series of chemical reactions, transformed into energy to move muscles, heat bodies, and perform countless other vital functions. But what happens to this energy after it's used? It doesn't disappear. Instead, it transforms into less useful forms of energy, heat, for instance, and dissipates into the environment. This is entropy in action. Useful energy is constantly transformed into less useful energy, and over time, this less useful energy spreads out so much that it can no longer be used to do work. This process is inevitable, and that's why the entropy of the universe is always increasing. You can think of entropy as a kind of cosmic clock. As entropy increases, the universe moves toward its final destination, a state of maximum disorder, where all energy is so dispersed that nothing more can happen. This final state is known as the heat death of the universe. It sounds like a gloomy prospect, doesn't it? But fortunately, this is billions of years away in the future. Now, think about how entropy affects not just the cosmos, but also our daily lives. When you put ice in a glass of water, the ice melts, and the cold water mixes with the warmer water until everything reaches an even temperature. This is a simple example of how entropy works. Thermal energy spreads out evenly, creating a state of balance. And this is exactly what entropy does on a cosmic scale. It moves everything toward equilibrium. But why is entropy so important to life? In many ways, life is a constant battle against entropy. Living beings are highly organized systems that require a constant flow of energy to maintain that organization. Think about your body. Every day, you consume food that is broken down and converted into energy that your body uses to keep your cells functioning, repair tissues, and perform all the other functions necessary for survival. But eventually, that energy is dissipated and you need more food to continue the cycle. This struggle against entropy is what drives life. Without it, there would be no need to consume energy, and life as we know it would not exist. It's a delicate dance, absorbing energy, using it to create order, and then dissipating it as heat. This cycle repeats continuously in every organism and is essential for the existence of life. Now let's think about the universe as a whole. When the universe was born after the Big Bang, it was extremely hot and dense, with low entropy. But as the universe expanded, it began to cool and organize. Galaxies, stars, and planets began to form, creating structures of order in a universe that, ultimately, is destined for chaos. This temporary organization is what allows the existence of complex things, like life. However, entropy never stops increasing. Even as new stars are born or new galaxies form, the total amount of entropy in the universe continues to grow. One day, the stars will die, the planets will cool, and the entire universe will become a cold, dark place where nothing else can happen. But until then, there is so much we can explore and learn about how the cosmos works. One of the most fascinating aspects of entropy is how it relates to the concept of time. For most laws of physics, time is symmetrical. They work the same way forward and backward. But entropy is different. It gives us a direction for time, known as the arrow of time. It's because of entropy that we perceive time as something that moves forward. It's the continuous increase in entropy that makes the past different from the future. And the curious thing is that if we could reverse entropy, we could theoretically reverse time. Of course, this is pure scientific speculation, but it's interesting to think about the implications. What would a universe where time runs backward look like? Where entropy decreases and order spontaneously increases? This speculation leads us to another intriguing question. What would happen if we found a way to control or decrease entropy? This would theoretically allow us to extend life, create inexhaustible sources of energy, or even alter the flow of time. These ideas, though they seem like science fiction, are based on real physical principles. Controlling entropy would mean controlling the fate of the universe, something that, for now, is beyond our technological capabilities. However, entropy also gives us an interesting perspective on the fragility and preciousness of life. We know that life on Earth exists only because our planet is in a state of relatively low entropy, constantly receiving energy from the sun. But this situation won't last forever. Eventually, the sun will become a red giant and engulf the Earth, and even before that, life as we know it may be threatened by a series of cosmic events. This means that life, in its organized state of low entropy, is a temporary phenomenon in a universe that is constantly moving toward chaos. Entropy is more than just an abstract concept in physics. It's a fundamental force that shapes the universe, from the birth of stars to the ultimate fate of the cosmos. It governs the flow of time, the evolution of life, and even the destiny of galaxies. And while the increase in entropy means that the universe is moving toward a state of maximum disorder, it's also this very force that allows for the existence of all the beauty and complexity we see around us. Now that you know more about entropy and its influence on everything that exists, what else would you like to learn about the cosmos? Let's continue this conversation in the comments. Thank you for staying with me until the end, and I'll see you in the next video.